All right, let's take a look at the Chapter 8 PowerPoint lecture slide for producing data sampling. In Chapter 8, we covered population versus sample, how to sample badly, simple random samples, inference about the population, other sampling designs, cautions about sample surveys, the impact of technology. Watch for these points. A sound statistical design is necessary if we are to trust data from a sample or drawing sound conclusions about the population. In sampling from large human populations, however, practical problems can overwhelm even sound designs. The impact of technology, particularly cell phones and the internet, is making it harder to produce trustworthy national data by sampling. Population versus sample. The distinction between population and sample is basic to statistics. To make sense of any sample results, you must know what population the sample represents. Population sample sampling design. The population in a statistical study is the entire group of individuals about which we want information. A sample is the part of the population from which we actually collect information. We use information from a sample to draw conclusions about the entire population. A sampling design describes exactly how to choose a sample from the population. The first step in planning a sample survey is to say exactly what population we want to describe. The second step is to say exactly what we want to measure, that is, to give exact definitions of our variable. How to sample badly. A sample selected by taking the members of the population that are the easiest to reach is called convenient sample. Bias. The design of a sample is biased if it systematically favors certain outcomes. Caution. People who take the trouble to respond to an open invitation are usually not representative of any clearly defined population. In a voluntary response sample consists of people who choose themselves by responding to a general appeal. Voluntary response samples show bias because people with strong opinions are most likely to respond. Simple random samples. Random sampling. The use of chance to select a sample is the central principle of statistical sampling. A simple random sample, SRS, of size n consists of n individuals from the population chosen in such a way that every set of n individuals has an equal chance to be the sample actually selected. In practice, people use random number generators generated by a computer or calculator to choose samples. If you don't have technology handy, you can use a table of random digits. How to choose an SRS. A table of random digits is a long string of the digits 0 through 9 with the properties that each entry in the table is equally likely to be any of the 10 digits 0 through 9. The entries are independent of each other, that is, knowledge of one part of the table gives no information about any other part. Table B to choose SRS. Step 1, label. Give each member of the population a numerical label of the same length. Step 2, table. Read consecutive groups of digits of the appropriate length from table B. Your sample contains the individual whose labels you find. Here is an example. So we're going to use the SRS table B to select 4 hotels at random. The first thing that you do is alphabetically order your hotels, and then number them from 1 to however many hotels that you have. If it's a double digit, then your ones place values also have double digits. If you make it to the hundreds in your list, then your single ones place digits have 3 digits, 001. Here's an example where there's 28 hotels, so double digits, so 01, 02, 03 are choices. If we look at this row in the table, then select every 2 digits to be a number. So 69, form a number. 05, form a number. 16, form a number. 48 forms a number, and so on, until we've parsed this list out into 2-digit numbers. Now, to select the 4 hotels, you go through this list. We see a 5, we have a 5 on the list. We have a 16 on the list. We don't have a 48. We also didn't have a 69, by the way. We don't have a 17, or we do have a 17. We don't have an 87. We already chose 17. We don't have any of these other numbers, and we already chose 17. And then we have a bunch of numbers we don't have, and then we have the 20. So to select 4 hotels at random, our SRS of 4 hotels for the editors to contact is number 5, Beach Castle, number 16, the Radisson, number 17, the Ramada, and number 20, the Sea Club. Inference about the population. The purpose of a sample is to give us information about a larger population. The process of drawing conclusions about a population on the basis of sample data is called inference. Why should we rely on random sampling? 1, to eliminate bias in selecting samples from the list of available individuals. 2, the laws of probability allow trustworthy inference about the population. Results from random samples come with a margin of error that sets bounds on the size of the likely error. Larger random samples give better information about the population than smaller samples. Other sampling designs. The basic idea of sampling is straightforward. Take an SRS from the population and use your sample result to gain information about the population. Sometimes there are statistical advantages to using more complex sampling methods. One common alternative to an SRS involves sampling important groups called strata within the population separately. These subsamples are combined to form one stratified random sample. Stratified random sample. To select a stratified random sample, first classify the population into groups of smaller individuals called strata. Then choose a separate SRS in each stratum and combine these SRS to form the full sample. Another example is multi-stages samples. Caution about sample surveys. Good sampling technique includes the art of reducing all sources of error. Undercoverage occurs when some groups in the population are left out of the process of choosing the sample. Non-response occurs when an individual chosen for the sample can't be contacted or refuses to participate. A systematic pattern of incorrect responses in a sample survey leads to response bias. The wording of questions is the most important influence on the answers given to a sample survey. The impact of technology. Expense of personal interviews to do surveys has led most studies to technology-based data collection. Issues. Random digit dialing has grown decreasingly useful as the proportion of homes with no landlines has increased. Web surveys are used more frequently but are difficult to do well.